Today, I'm delighted to welcome Sospeter Kibiwot, who is a small mammal biologist specializing in the order Chiroptera. He's currently working as a bat monitoring expert at Kipeto wind farm in Kenya. And Sospeter has a tourism and wildlife management diploma from Moi University in Kenya, and also a BSc in wildlife management from the University of Eldoret in Kenya. And it was during his undergrad that he was introduced to bats for his final year undergraduate dissertation, where he decided to investigate the influence of human activities on bat abundance and species richness on riparian parts of the Kipeto River in Kenya. Sos is a Master of Science student at the moment in Eldoret University, and his thesis focuses on investigating the effects of forest degradation on bats at South and North Nandi forest in Kenya, and I believe that's what he will be talking to us about during today's webinar. And just to say also that SOS is currently looking for PhD opportunities. So if you know of any relevant opportunities coming up, please let him know. I'm sure he would be interested to hear about them. So welcome, Sospeter, and over to you. Really looking forward to listening to your talk.
Okay, thank you. Thank you, Elisa. I'll proceed to share my screen. I hope you can all see my screen now. Can you?
Yes, we can. Thanks.
Yeah, thank you. Thank you so much for giving me this opportunity to do a presentation on what I've been doing. I'll be taking you through the effects of forest degradation on birds in South and North Nandi forest, which is located in Western Kenya. My mentors are Dr. Paul Webala and Dr. Johnson Kimanzi. And the great picture you are seeing before the screen is was taken by one Bruce from the Field Museums of Chicago. Tropical forests in Africa are basically hotspots for biodiversity. And in Kenya, we really don't have as such tropical forest, tropical rainforest as that is like the ones in West Africa. As you can see in this map, most of the forest covers along the Western Africa, Central Africa, Congo, and Kenya is located somewhere here. So what we have in Kenya is basically a remnant of the Kini equatorial forest. And the remnant of this forest in Kenya are basically 2 or 3 forests. One is a famous one by the name Kakamega Forest, which is located somewhere here. And the other 2 are the South and North Nandi forests, which lies to the far eastern side of the continent. These tropical forests or rainforests are facing a number of threats. And there are those which I saw, and it has been documented that they are more of direct threats to the tropical forest and habitat in general. And one is habitat loss, fragmentation, and degradation. Habitat loss has really contributed a lot to loss of biodiversity. And this has contributed more due to increase in human population There's also the threat of unsustainable harvesting or of exploitation of resources, which is also connected to population growth. The other direct threat is invasion by alien species. In most of our tropical forests, especially where I'm undertaking my research, the cases of Lantana camara and some exotic plant species which were introduced in the forest to this unsustainable harvesting and overexploitation of resources the overexploitation and harvesting of resources has not been capped by the government because of poor policing and poor enforcement of policies that are in place. There is the issue of pollution. Most of these tropical forests, rainforests, are major sources of water. And in the case of Nandi forest or Nandi ecosystem, there are so many streams of rivers flowing through the forest, and all are pouring their waters to the Lake Victoria Basin or Lake Victoria. And there are so many agricultural activities going around the forest, so many pesticides, and there's a lot of pollution of the water resource, which basically affects several organisms, including other mammals. So that is one of the direct threats that is facing the forests. Other threats are encroachment, change in land use, resettlement, and climate change. Encroachment arises also due to population increase, whereby people are looking for space to tilt, to plant, to rear the animals. Likewise to resettlement. In Kenya, there have been instances whereby the government allocate land to resettle squatters. And for the case of the forests that I'm working in the year 1968, a total of 410 hectares were used to resettle squatters, and that's a great loss. There's the issue of climate change. I believe normal, everyone in Kenya, like the normal citizens who are not cautious of what is happening, don't really understand the issue of climate change because the temperatures, they feel it's the same. They can eat and relax. So the issue of climate change has not really hit the Kenyan population as it has been expounded more in the literatures. For the case of, like the case of Mount Kenya, the extent of glaciers has really dropped. If you read deep on the extent of the glaciers, like 10 years ago, and now the level of ice has really dropped. And that is a clear indicator that climate change is really staring at the different habitats. Flora and fauna of the Nandi ecosystem and Kakamega forest in general because they are more adjacent. There are about 600 plant species, including trees, shrubs, ferns, flowering plants, and orchids. And some are endemic to this tropical forest. There are around 367 bird species. And the three forests, the Kakamega forest, Nandi and South Nandi forests, are all important birding areas. There are over 489 butterfly species. There are also around 40 snake species. And mammals are also quite in large numbers, including primates, though we don't have like the megafauna, like the elephants, except we have the records of leopards, which are not so much recorded currently. And we also have an interesting species like the tree pangolins. We have the poto, and so many other mammalian species occurring in the forests. As I said before, the species-rich tropical forests are becoming increasingly fragmented and degraded due to habitat loss and fragmentations. There's not much been done to account on the continuous pressure that is destroying the world rainforests. No one has really accounted for the much that is being lost yearly along the tropical forests of the world. And that is why our study investigated the effects of forest degradation on birds. In these two forests, which I call Nandi ecosystem, little has been done. For the case of birds, nothing has been done. This is the first study. And the studies that has been done so far only concentrate on flora and the bird species occurring in the forests. The first study was done in 1998, assessing, determining the potential for introduction and sustaining participatory. And some of these studies are very old, though very informative, but nothing has really changed. The most current study undertaken was the one that was done by David at South Nandi Forest, which also concentrated on the flora, whereby he was working on a tree species that is endemic to the forest. And the findings were that the tree species that he was concentrating to work on is really declining due to over deforestation or over harvesting due to medicinal issues or medicinal benefits of the tree is researching on. The most relevant study to my work is the one that was done at Kakamega Forest by Dr. Paul Webala, whereby he investigated the effects of habitat fragmentation on the birds of Kakamega Forest. And in this study, he recorded 26 bird species, which corresponds with my findings. So in his studies, he concentrated his research collecting data using captures, and he didn't utilize the acoustic methods, which in my case, it will be a different method from what he did. And whatever species is occurring at Kakamega Forest, there's a high probability that the same species will be occurring at North Nandi forests and the South Nandi forest. My objectives were to compare bat abundance and species richness along a gradient of disturbance. Also to assess the influence of human activities and disturbance on different bat species and species assemblages at both forest. To establish a comprehensive local echolocation core library of bats at both forests, and also to sensitize the local communities on what bats are, the ecosystem roles, need to conserve them, and why forests are important and need to conserve them for bats and other fauna. My predictions were low bat abundant species richness at a degraded forest compared to less disturbed forest, and bat response to fragmentation vary widely among bat species and between functional groups or assemblages. Methods. My study area, I concentrated on the two forests, the North and the South Nandi forest. These two forests are about around 30 kilometers wide apart. And the strip of the two forests range between 3 to 5 kilometers wide. And the management of the two forests are within Kenya Wildlife Service, only a section of South Nandi Forest, but entirely the North Nandi Forest is managed by Kenya Forest Service. These two forests have plantations. It's not only the indigenous forest species, but there is a lot of introduction of exotic species. This exotic species was introduced in 1979 by the government of Kenya to increase the demand for timber at Webuye factory that was dealing on paper, even though the factory currently is no longer working. But the two forests have quite huge tracts of the forest and plantations of eucalyptus, cypress, and other exotic species. North Nandi Forest has a total mass of 10,501 acres. And the South Nandi Forest has a total of 19,502 acres. In 1936, when the forests were gazetted, South Nandi had a total of 20,200 acres, and North Nandi had a total of 11,850 acres. Of this mass area, as you can see, there's a reduction of around 900 in North Nandi. And in South Nandi, there's also a reduction of some land. And all this was degazetted by the government to settle squatters. Some was degazetted to create a buffer zone, which we call the Nandi T-zone buffer zone, which runs along the borders of the forest. That is why the gazettement of 1936 and the current status of the forest, the size of the forest, don't match. Even though the figures reads 19,000 acres and 10,000, if a clear or a more elaborate study is carried out to determine the percentage of forest cover, I believe it's less than what is written, because there's been a lot of encroachment for farm use, farmland, agriculture, grazing, and so many other activities. There's also the issues of land grabbing that has really affected these two forests. Methods. I employed 3 methods whereby all my samples, I sampled the data using mist nets, whereby I used 6 mist nets, 2 herb traps, and 3 detectors at every point. In my study area, I walked along the matrix, the edge, and the interior to assess the effects of forest degradation along these 3 gradients. For mist nets, I ensured a consistent number of mist nets along my sampling sites, whereby I maintained 6 mist nets, 2 herb traps, and 3 detectors per point. In the matrix, I pre-selected 3 sites, which I surveyed 2 times every visit. And I visited the different sites 3 times within a period of 7 months. I repeated the same with the herb traps and the acoustic detectors, whereby the matrix, I recorded the matrix between 100 meters from the edge of the forest towards the farmlands. And the edge of the forest, it was between the edge of the forest and 200 meters into the forest. And beyond 200 meters, that is where I treated as the interior. Also in my methods, I visited different caves, which I located with the assistance of the local communities. I also visited schools to sensitize. I visited worship places. I also organized barasas to interact with the community to enable me sensitize the community. Also, every samples of birds collected, a few were collected as forger specimens and were deposited at the National Museums of Kenya. And I would release the remaining bird species for the case of micro Chiroptera to get the reference calls that I will be using, that I was to use to develop the call library. All the groups of birds collected were categorized into frugivores, edge-open species, foraging insectivorous species, or narrow space foraging insectivorous species. To determine or to compare the effects of forest degradation and justify, I used 20 by 20 meter plots at each capture site, where I measured the tree density, charcoal kills, number of cut tree stumps, footpaths, and if there were presence of saw pits. For my analysis, the dependent variables were the vegetation parameters. That was the tree density, charcoal kilns, footpaths, and saw pits. But abundance, I checked the factors of capture per location and detector per location. I also used kaleidoscope to analyze my acoustic data. And in general, I also used the two-way multivariate ANOVA analysis to present the results of these different variables. In my results, it's not up to date because I was still working on the acoustic data to enable me bring everything in a well-presented manner. So for now, I'll be presenting what is available and what I've done so far. And for this case, I'll be presenting the results of bat abundance, whereby in my data, the age at the highest abundance in the two forests, followed by the matrix, while the interior had the least abundance. To explain it more on the abundance, both forests, the matrix had a total of 2,280 cumulative abundance. The edge at 3,280, comprising 16 species, and the interior had a total of 443, comprising 17 species. Altogether, the cumulative frequency was I had a total of 6,003 captures, which comprised 21 species. And in this case, the relative abundance I'm presenting here is only for the captures. And for the case of the South Nandi forest, the total birds captured were 2,566. And the age had the highest number of species, which was 15, followed by the interior, even though the number was small, but the species richness was higher. And in North Nandi forest, the interior had the highest species number of 16, followed by the age, which had the highest abundance of 1,805. In total, the North Nandi forest had the highest number of birds captured, which accounted of a total of 3,437, comprising the 21 species, while the South Nandi was less by around 4 species. So North Nandi was more richer as compared to South Nandi forest. A more detailed representation of my data is as shown below in this table. And you can see the high number of species captured, or the high number of individuals captured, was due to the high, was accounted because of the high number of Epomophorus labiatus and Wolbachii, which in this case accounts for over 50% of the total captures per per site for the case of North and South Nandi forest. The two species were the highest, were the most captured or most encountered in my studies. A representation of the vegetation parameters, which is basically the tree density and the number of stumps density. South Nandi forest, the matrix had the lowest tree density, followed by, which is the same in the case of North Nandi forest. So the matrix had the lowest tree densities, followed by the edges, and the interior had the highest tree density. For the case of cut tree stumps, the interior had the least, but for the case of North Nandi forest, the number of cut tree stumps was higher in the areas I did my plots as compared to the edge. So the edge and the interior of the two forests don't have much differences, while the matrix had the highest number of cut tree stumps all combined. In this picture here is a Croton megalocarpus tree that is, it was in the interior of the forest, and I was surveying where I will be placing my mist nets that night. And I just encountered this tree that had been felled using an axe. And you know, all these places under monitoring of the Kenya Wildlife Service and the Kenya Forest Service, as earlier said on the management. But there is a lot of tree cutting in and out of the forest. Here, in this photo to the right, is North Nandi forest. And if you can see inside or far into the forest, you see a lot of empty spaces. They are not really glades, but they are farmlands. The management of these two forests allow the local community to farm inside the forest, whereby they go and clear the forest. So if you scan the forest from a distance, you think the forest is really intact, but in real sense, the forests have been really degraded, and there's a lot of pressure being inserted into the forest. Here, as you can see, these guys here, this is also a recreational site where people come and party. They collect firewood from the forest and used to roast their meat, light fires. And in some cases, they don't put off the fires. So luckily, the forest is so wet and it rains most of the time. So there are no incidences of fires. And in this other side, to the left, is South Nandi forest. This clearing is inside the forest. It was like 500 meters into the forest. And there's a very huge tract of land where the local communities have cut trees to start gardens where they plant vegetables in large scale under the watch of the forest management. And they come to monitor, they go around the place and nothing is being done. So as you can see, these are all stumps of trees. I counted around 20 tree cut stumps in this area. And there was a continuous process of expanding the land to allow the farmers grow their vegetables. Also, this other tree stump was within the same area, and they're expanding. As you can see, the back of this stump had already been peeled. So there's a trend whereby if they want to clear the forest, if they want to farm within a certain side of the forest, they debark the tree, and within no time, the tree will dry up, and they go and cut it down. So if you go around the forest, you may think that there's a lot of medicinal plants being harvested because of removing of the tree bark. But the whole concept of cutting or removing the barks of the trees are to make sure that the trees dry up and allow the farmers to go in. Acoustic monitoring. In the acoustic monitoring, I recorded a total of 64,655 calls, which I just finished analyzing 2 days or 3 days ago. And this was a challenge to analyze these calls because I'm using the free kaleidoscope and I had to go through call by call. So in this acoustic monitoring survey I did at the 2 forests, North Nandi forest had a total of 25 species, and the South Nandi forest had 22 species. In these 2 forests, the total number of species combined was 26, not putting into account what I recorded through captures. And the part activity is shown in the table, whereby the age always had the highest number of bat activity as compared to the matrix and the interior. Even though the matrix at some point had a little higher number, but the interior had the least bat activity or calls recorded. Even though the calls recorded in the interior were basically the specialist or gleaner species, even though, and also in the interior of the forest, we recorded a number of molluskids, which are high flyers. And that doesn't mean that they are so much into the forest as compared to the special species. Also in the picture is Paul Webala, who is my supervisor. He was working on the SM4 detectors. In this other table, I compared the trapping and the acoustics, whereby in trapping, we had a total of 21 species. Of these 21 species, 6 were fruit bats. And I trapped Miniopterus natalensis, which made the 7 species which was not recorded in the acoustic monitoring. While the acoustic monitoring managed to bring additional species, 11 additional species, to what I had earlier recorded through the captures. So in total, the total number of species I recorded when I combine the acoustic and captures, I had a total of 35 species falling within 8 families, falling within 7 families. In total, 8 families, including the captures, but for the acoustics, I collected data falling within the 7 families. In this case, when I compare the findings here and what Dr. Webala recorded in Kakamega Forest, he managed to record 26 species. And with the help of acoustic data, monitoring, I've managed to record a higher number by 9 species. And in this case, South and North Nandi forest are more degraded compared to Kakamega forest, which is also huge in size. So the introduction of acoustics was a plus to this survey, and putting into account that this is the first study ever done in this forest. So I believe going forward, if I'll get a chance to get deep into the forest and move into the different sites, the species number will definitely rise, and understanding the different parameters and use of softwares, I believe the number of species will really go up. In developing the core library, I've managed to annotate around 35 species of birds. I had to take a different angle, not only to annotate the calls from North Nandi and South Nandi forest, but to take a bigger picture of utilizing the calls collected from elsewhere in Kenya to develop a call library for Kenya. So I've managed to annotate 35 species, and I still have a good number of data. And I'm targeting by the end of September, with the help of Dr. Webala, we are targeting around 70 bird species or 60, whereby we'll have a working core library for birds of Kenya. In this software, which I was assisted, I'm also under assistance from Holly and Santiago from UK, who developed this program for us. And I'm really working hard to ensure that the core library is functional anytime soon. As you can see in this table, I've managed to annotate Pipistrellus ruepeli, which I didn't record in the 2 forests. I've also annotated Kerufola, which I didn't record at North Nandi and South Nandi forest. And also the software I'm using needs to be trained to detect other calls that don't belong to birds. And I also trained by using the different calls that I record that don't belong to birds, but insects and other organisms. And in this software, you need to draw boxes in every call, and I'm focusing an average of 10 calls per species to reduce the error and biasness. So this is the first step, whereby you draw boxes along the calls. Then the parameters that the software uses at the high frequency, low frequency, duration, and frequency range, and also the mean and standard deviation of the calls. So these are just the inception, the first stages of the software. And going deep, the software will pick an annotated call that represents all the calls that you have annotated for that species, and also gives a graphical representation of each and every species calls using different graphs, distribution plots, duration, histograms, and so forth. So this is a software that I'm still training on, though for now I can say I'm pretty good to develop this core library for Kenya. In my local community sensitization activity, I visited different schools and also places of worship where I gave talks to the pupils, students, and the church members concerning the roles of birds, training, using pictures, and giving them some books to read for conservation, not only for birds, but a general knowledge for conservation. So in the first picture, I visited a nearby secondary school where I interacted with several students. And in my last day, I presented what the pupils raised that they were missing in terms of books. So I bought a number of books for the school and also included a guideline for the birds of Kenya that was written by Bruce Patterson and Paul Webala in 2012. So I gave some number of copies to this school and motivated the students not only to have a negative attitude towards birds, because in Africa, there's a lot of negative attitude and perception on birds. I also visited primary schools, and a few primary schools pupils showed interest to see what I was doing. And I had to organize for a session with the pupils, where I visited a nearby cave. This was before time of Corona. That is why I was working with the students, the pupils. I visited a nearby cave where I trapped some birds and used to teach the pupils. So they were really interested to go into the caves, but I didn't allow the pupils to go into the caves. And in this other picture, it was after a church function, a church service, where I had visited and had a talk with the congregation. In all this local community sensitization, before COVID, the reception and the attitude was really good. I managed to change the negative attitude and perception on birds. But come March 2020, when the issue of COVID arose, everything changed because it was all about bats. So when I tried to visit back the different places I visited, they were saying like, this guy works on bats and maybe he has COVID. So everybody was running away, didn't want to interact with me, and no one was really interested on bats. Also, during my local community sensitization program, I managed to assist a few families which had bats roosting in their homes. And I put lights in their roofs and sealed off the areas that these bats were getting into their homes. And it was my objective that if I had some more funds, I was thinking of developing bat boxes, which I really intend to do in the near future for the local communities, because if we seal these roost sites, where will the birds go? The forests are being fragmented, they're being destroyed. So if we seal off their roost sites, which they find refuge, where else will they go? So I was thinking of developing bird boxes in the local areas to assist, give room or home for these birds. Bird composition and similarities. Edges and interiors of the two forests recorded similar percentages of 58, 52, 8.06, and 6.87 shared species for South and North Nandi forests, respectively. In both forests, frugivores had a total of 3,427, which accounted for over 61%, which were frequently captured at the matrices edge, though a few were captured in the interior, and insectivores and narrow space foragers were dominant in the interiors of the forest. In the interiors of the forest, the narrow space specialists accounted for over 58%. Birds of North Nandi ecosystem. These are just a sample pictures from what I collected in North Nandi forest. Epomovorous labiatus, Walbagi, Scotophilus, and Rebori, Rhinolophus, Tavosoas, and another Tavosoas, Nycteris. For the case of Nycteris, I really didn't manage to get into the species level, but I'm waiting results, confirmation from the National Museums of Kenya on the species of Nycteris that I collected at North Nandi Forest. I also had a number of Minioptera species, Rhinolophus eloquens and Hildebrandidi. I collected also Myotis species in one of the caves. Rosetta's Aegyptiagus was common. Another Nycteris species which I collected at North Nandi Forest. For the case of Automops arizoni, which is in the picture, I didn't really collect trap, but these are just confirmation through the acoustic monitoring. Also, for the case of some rhinolophids, which I didn't really trap, but I would find their calls in the acoustic data. The team that I worked with inside with the background of the hub trap, was my other supervisor, Dr. Kimanzi. And this day we were together in the field with Dr. Paul Webala, where we stayed for 8 days with them in the field, collecting and walking through the areas that I was doing my studies. To the left down is Benjamin, which was a local guide and also a porter, because most of the forest terrains were impassable. And that was my vehicle which I used during my survey. In conclusion, frugivores and edge open space parts were marginally affected by fragmentation effects. Forest specialists showed positive association with forest variables, whereas frugivores responded positively to the human use indicators in the highly disturbed matrices and edges. Accordingly, the species specialists appear to be especially vulnerable to forest loss and degradation. This was evident with the fact that I trapped a number of frugivores in the interiors of the forest. Acknowledgements, I would like to acknowledge Bat Conservation, BCI, for their funding, and also Ruford Foundation. I also would like to acknowledge my university, Kenya Wildlife Service, for their permits, and Kenya Forest. Also acknowledging Bats Without Borders and the AfriPopo programs for allowing me to do this presentation with you today. Not forgetting the Field Museums of Chicago, which also funded my project through Dr. Paul Webala. Thank you so much.
Thank you very much, Sospeter, for that excellent talk. And it's really impressive to see all the different components of your project, looking at the effects of fragmentation on bats, but also developing that call library, which sounds like an amazing resource, and even doing some community engagement as part of your project. So well done. And thank you very much for talking us through all of those different aspects of your work. We are running a little bit over time, but we'll spend a few minutes going through the questions on the chat. Rachel is asking about your call library and whether or not you developed it from scratch, or if you have an initial call library to work from.
The whole library, I'm developing it from scratch. I'm just starting, yeah.
Sounds like hard work, I guess. Especially, you said you had like 60,000 recordings from your data. Is that what you're using for your call library, or are you also using other existing resources?
Okay, I'm using what I recorded during my studies, but because I said I thought of expanding it to cover the entire of Kenya, I requested Paul Webala to give me what he has, and he gave me over 200 gigabytes of data. So I'm still working on that data to separate the different species from his recordings as well.
Well, it sounds like really interesting and important work. So yeah, looking forward to the output coming from that. We have another question about the attitude of forest authorities to bats and the need to conserve the forest. Can you say a little bit more about that?
Conservation of bats in Kenya is really, it's not a matter of the authorities. if we can go through the Act of Conservation, which was developed in 2013, the issue of birds has not been captured else anywhere. So the perception and attitude of the authorities don't recognize birds. So it's an African setup and no one understands birds. No one likes birds. Yeah.
Yeah, it was also really striking what you said about the perceptions of people, how that changed during and after the pandemic. So just kind of emphasizing the importance of community engagement and just dissemination of why bats are such an important component of ecosystems. Another question about whether or not do you think COVID has increased, for example, poachers and others destroying bat roosts?
Yeah, there's a program that I was participating on, which we were surveying the edol on elfum. We were monitoring and doing counts of edol on elfum in Western Kenya. And in some cases, the roosts, you would find people lighting fire below the roosts because edol and elfum roosts on trees. So you'd find huge fires being lit below the roost sites. So at the end of the day, when you go back there, you won't find birds.
There's another question about whether or not there's an understanding of the role of bats, for example, in reducing pest insects and providing pollination services. And I guess that relates a little bit to a question that I had about the species composition and the different functional roles and the differences between forest interior and the matrix, with frugivores and insectivores kind of forming different communities in these different parts of the forests. So you think those results could potentially be used to inform people and tell them a bit more about how the different bat species in those areas, what they might contribute to the ecosystem and how people may benefit from that?
For this case, the role of bats in reducing pests, insects, and pollination, and this seed dispersal has not been researched or been studied in Kenya. So I was using the knowledge and literature from elsewhere to educate the locals on the roles of bats. But in Kenya, there are no research that has ever been done to assess the role of bats. Yeah.
Well, that highlights why it's so important to have studies like yours and hopefully many others to follow, just to better understand the importance of bats and how we can use those findings to inform bat conservation actions across Africa. So just because of time, I think we'll stop there. There's more questions in the chat. Apologies if I didn't get to your question. There's also lots of comments saying great talk. Thank you very much for your presentation. So yeah, I would just like to reinforce those comments and say thank you, Sospeter, again for coming and speaking to us today. And thank you everyone for joining us. And I hope you continue to join us in future webinars and other events. So yes, thank you everyone. Enjoy the rest of your afternoons and hopefully see you again at one of our webinars soon. Thanks everyone.
Thank you.